Hello everybody and welcome back to another Algebra 1 video. Today we will be covering lesson 9.1 on how to solve quadratic equations by graphing. Now I know in my previous video I had just started covering chapter 5 on the domain and range of a function. However, I do realize that the school year is nearing to an end. So as requested by a fellow viewer, Joanne, I will be fast-tracking to Chapter 9 and trying to align all my future content with the current school year. And then once I've finished all that content, I'll go ahead and return back to cover everything in between. However, again, for today's video, we will be learning lesson 9.1 on how to solve quadratic equations by graphing. First, I just wanted to get started with a brief introduction into what a quadratic equation is. So you might have worked with quadratic equations before in your Algebra 1 classes, and I think that might have been in Chapter 7. And you might remember that the quadratic equation forms this almost U shape on the graph that's called a parabola. And that's what we'll be working with in today's lesson. So a quadratic equation is a nonlinear equation that can be written in the standard form ax squared plus bx plus c equals 0, where the value a cannot equal to 0. In Chapter 7, you solved quadratic equations by factoring. You can also solve quadratic equations in standard form by finding the x-intercepts of the graph of the related function y equals ax squared plus bx plus c. Since today's lesson does deal a lot with graphing, I just wanted to share a quick tip for how to graph quadratic equations faster. So we know that the parent quadratic function is y equals x squared. And this is when the graph has a vertex at 0, 0, or the origin. And then usually whenever you find your vertex, you want to find 2 points that are to the left of your vertex and 2 points that are to the right of your vertex. So in this case, you would plug in -1 and -2, and then +1 and +2. And if you were to do that, -1 squared would just be +1, so that would be -1, +1 right here. Plug in -2, you would just get +4. That would give you -2, +4. As for the 2 points to the right of the vertex, if you were to plug in +1, you would get +1. And then if you were to plug in +2, you would get +4. And then you can smoothly draw a line through your points and create your parabola. Now, if you look at the pattern that this graph creates, you might notice that if you go 1 unit to the left of the vertex, then you would go up 1 unit, and same goes for if you were to go 1 unit to the right of the vertex, you would go up 1 unit once again. And then if you were to go 2 units left from the vertex, you would go up 4 units, and same goes for if you were to go 2 units right from the vertex, you would also go up 4 units. So since we are working with graphs that have 1 for their a value, meaning that there's no other value other than 1 in front of our x squared, as long as a equals 1, the rest of the points will generally follow this same pattern of 1 unit left or 1 unit right and 1 unit up, and then 2 units left or right, and then 4 units up, etc. The only part of the graph that will change is this vertex point right here. So what I recommend is that you try to be able to memorize this pattern right here so that you can easily graph your parabolas. So I'll go ahead and show you how we would do that in an example. For our first example, we're going to solve x squared plus 2x minus 3 equals 0 by graphing. So step 1, we're going to graph the related function. And when they say related function, they just mean to replace this equals to 0 to equals to y. So since we are in standard form, which is ax squared plus bx plus c. We do have to find the axis of symmetry so that we can find the vertex. If you don't remember, the equation for the axis of symmetry is x equals to negative b over 2a. In this case, our b is going to be positive 2, so substitute b for positive 2, and then over 2a, our a value would just be 1 since there is nothing in front of our x squared. So that would give us negative 2 over 2 times 1. That would just be negative 2 over 2, and that would give you negative 1. So we know that our axis of symmetry is at negative 1. So you can just draw a dotted line through negative 1 on the x-axis. Now the axis of symmetry is x equals negative 1. So we know that the x-coordinate of the vertex is also going to be negative 1. So we're going to use the function that we were given to find the y-coordinate of the vertex. Again, your function is y equals x squared plus 2x minus 3. The function is already set to y, so all you have to do is plug in negative 1 for all your x values. You would get negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared simplifies to positive 1, then plus negative 2 minus 3. 1 plus negative 2 is just negative 1, and then lastly subtract 3, and you get that your final y value is negative 4. So make this into an ordered pair. Your x value is negative 1, and your y value is negative 4. So your vertex is going to be at negative 1, negative 4. Now taking into account the tip that I shared at the beginning of the lesson, we see here that our a value is still 1. So you can actually just follow the same pattern that we learned in the previous slide to graph the rest of your points. Following that pattern, remember that if you go 1 unit left from the vertex, you would just go 1 unit up. Same goes if you were to go 1 unit right, you would also go 1 unit up. If you go 2 units left from the vertex, you would go 4 units up. And notice how this hits our x-axis right here. And then if you're going to go 2 units right from the vertex, you would go 4 units up. And now that you have 5 solid points to graph on your graph, you can now connect them with a line to create your parabola. And here is your finished graph. Now, to actually answer the question of solving the quadratic equation, you just have to find the x-intercepts, or where the parabola crosses the x-axis. Notice here that it's at negative 3 and positive 1. And your two solutions would just be that x equals negative 3 and that x equals to 1. And there are your two solutions. Here's another example. We have solve x squared minus 8x equals to negative 16 by graphing. So very first step, I'm going to rewrite the equation so that it's set to 0 instead of negative 16. And all you have to do is add 16 to both sides. And if you were to do that, that would give you x squared minus 8x plus 16 equals to 0. And now that you have a function that you can graph, you can go ahead and make the related function by replacing this equals to 0 to equals to y. And now I'm going to start graphing by first finding the axis of symmetry. Again, the equation for the axis of symmetry is x equals to negative b over 2a. In this case, our b is actually going to be negative 8. Make sure that you're looking at the sign in front of your b value so that you're writing it incorrectly. And then over 2a, our a is just 1. So that would be negative times negative 8 over 2 times 1. These two negatives would just cancel one another out, so it's just 8 divided by 2, and that would give you x equals 4. And now you can go ahead and graph your axis of symmetry at positive 4. Again, the axis of symmetry is x equals to 4, so the x-coordinate of the vertex is going to be 1. You're just going to take the equation that we're trying to solve, which is x squared minus 8x plus 16, and plug in 4 for your x value to find your y. So that would give you 4 squared minus 8 times 4 plus 16. So 4 squared would just be positive 16. Negative 8 times 4 would just equal to minus 32, and then plus 16. 16 minus 32 just equals to negative 16, and then negative 16 plus 16 cancels out and gives you y equals to 0. Now you can go ahead and put those two values together into an ordered pair for your vertex, so you would have 4, 0. And now you can go ahead and plot your vertex at positive 4, 0. Again, all the equations that we're working with have an a value of 1. So if you have ax squared plus bx plus c, notice that there's never a value in front of our x squared, so that would just be a 1. And since a does equal to 1, you're still going to follow the exact same pattern that you use for your parent function. So if you were to go 1 unit left from your vertex, you would go 1 unit up. 1 unit right from the vertex, you would also go 1 unit up. 2 units left from your vertex, you would go 4 units up. And 2 units right from your vertex, you would go 4 units up too. And now that you have your points, you can go ahead and plot them. Once you've plotted your 5 points, just go ahead and connect them with a smooth line to make your parabola. And here's how your finished graph will look like. And now all you have to do to answer the problem is find the x-intercepts. So again, the x-intercept is just where your parabola crosses the x-axis. In this case, actually, we only have 1 point instead of 2 points that cross our x-axis, and that happens to be our vertex for 0. So since you can only find 1 point that crosses your x-axis, your only solution would be x equals to 4. Okay, let's go ahead and do an additional example. We're going to solve x squared plus 4x equals to 0. Now our equation is already set to 0, so there's no additional steps that we're going to have to do to rewrite it. However, notice that in this case we don't have a c value. We just have ax squared plus bx. Now we're going to graph the related function, so just replace your equals to 0 to equals to y. And for our graphing process, I'm going to find and graph the axis of symmetry. Again, our axis of symmetry equation is x equals to negative b over 2a. Your b value in this case is positive 4, and then your a value is just positive 1, so that would be negative 4 over 2 times 1, and that would just be negative 4 over 2, and then simplify that to get x equals to negative 2. So for your axis of symmetry, you're going to draw a vertical line through negative 2 on the x-axis. And that's how it would look like. And now that we've found the axis of symmetry, let's go ahead and find the vertex. The axis of symmetry, once again, equals to x equals to negative 2. So the x-coordinate of the vertex has to be negative 2. We're going to use our equation to find the y-coordinate of the vertex. Again, our equation is y equals x squared plus 4x. All you have to do is substitute negative 2 for your x values. So that would give you negative 2 squared plus 4 times negative 2. Negative 2 squared is just positive 4. Then 4 times negative 2 is negative 8. So now you have 4 plus negative 8. That would just be 4 minus 8, which gives you y equals 2 negative 4. Now use those two values, your x and y value, and make that into a ordered pair. And your vertex would just be negative 2, negative 4. And now you can go ahead and plot that on your coordinate plane. It would be right here. And again, I'm just going to use the same exact pattern that we've been using from the parent function, since again, our a value is still 1. So if you go 1 unit left from the vertex, 1 unit up, you have a point here. Same goes if you go 1 unit right from the vertex. 2 units left from the vertex, you would go up 4 units, and then 2 units right from the vertex, you would also go 4 units. And here are your 4 other points, and now you can go ahead and connect them with a smooth line to create your parabola shape. And now that you've graphed your parabola, all you have to do is look at the graph and find where your parabola intersects the x-axis. In this case, it's at 2 points, negative 4, 0, and 0, 0. So you would just take the x values, so your final solutions would be x equals to negative 4 and x equals to 0, 0. And there's your final answer. Here is another additional example. We're going to solve x squared plus 10x equals to negative 25 by graphing. First of all, if we look at our equation, it's actually set to negative 25 instead of 0. So first step, you want to rewrite this equation just by adding 25 to both sides. So that would give you x squared plus 10x plus 25. And if you were to write the related function, you would just replace your equals to 0 with equals to y. And now that you have your related function, you can get started with graphing. First step, as we've been doing, is to find the axis of symmetry. Our equation is x equals negative b over 2a. Our b value in this case is actually positive 10. And this is because we have the form ax squared plus bx plus c. And so we would have 10 over 2 times our a value, which is just 1. And then that would still be negative, so we have negative 10 over 2, and that would just equal to negative 5. Now that you've found your axis of symmetry, you can go ahead and graph it on your plane. So vertical line through negative 5 right here. Now that we've found our axis of symmetry, we can go ahead and move on to finding our vertex. So the axis of symmetry is x equals to negative 5, so the x coordinate of our vertex is also going to be negative 5. So all we have to do is use the equation that we are given to find the y coordinate. So our given equation was y equals x squared plus 10x plus 5. All you have to do is substitute negative 5 for all your x values. So that would be negative 5 squared plus 10 times negative 5 plus 25. Negative 5 squared just equals to positive 25. Then 10 times negative 5 gives you negative 50. And then you would just have plus 25. So 25 plus negative 50 would just give you negative 25. And then if you add that to your other 25, negative 25 plus 25 just cancels, and your y value would just equal to 0. Now that you have both your x and y value, make them into an ordered pair for your vertex, and that would be negative 5, 0. Now that you've found your vertex, you can go ahead and graph it on your coordinate plane. Negative 5, 0 would be at this point right here. And once you've found your vertex, I'm just going to go ahead and use the same exact pattern to plot my other points. So just like the parent function, if you go 1 unit left from your vertex, you would go up 1 unit. 1 unit right from your vertex, you would go up 1 unit too. And then you would plot your points there. If you go 2 units left from your vertex, you would go up 4 units and plot your point. If you were to go 2 units right from the vertex, you would go up 4 units, and there is your other point. And now you can go ahead and draw a smooth line through your parabola. And here is how your final graph will look like. Once you've drawn your parabola, all you have to do is look at where it intersects the x-axis to find your solution. Again, like a previous example, our parabola only intersects the x-axis at one point, which is at -5, 0. So just taking the x value, your final solution would be x equals to -5. Here is an example for us to try. We're going to solve -x² plus 4x plus 5. Looking at our equation, we notice that it's actually set to -x². So to make our equation set to 0, all I have to do is add -x² to both sides. So that would give you 0 equals to x² plus 4x plus 5. And I recommend that you still write it in ax² plus bx plus c form. To get the related function, all you have to do is set your function to y rather than 0. And now that you have your related function, you can go ahead and find your axis of symmetry. Again, your axis of symmetry is going to be x equals to -b over 2a. Looking at our equation, our b value is +4. So that would be negative times +4 over 2 times a, which would just be +1. And that would just give you -4 over 2. So your axis of symmetry would be x equals to -2. And so you can draw your axis of symmetry through -2 on your x-axis. And here's how it would look like. Now that you have your axis of symmetry, we can find our vertex. So the axis of symmetry is -2, so our x-coordinate of the vertex is also going to be -2. You're going to use the function to find the y-coordinate. So just plug in -2 into your original equation, which is x² plus 4x plus 5. That would give you -2 squared plus 4 times -2 plus 5. -2 squared just simplifies to +4. 4 times -2 would just be -8, and then plus 5. 4 plus -8 would just give you -4 plus 5, and then if you simplify this, y would just equal to +1. Now that you have both your x value and your y value, just combine those into an ordered pair to get your vertex, and that would be -2, +1. You can go ahead and graph that on your coordinate plane. Now you can graph your remaining points from the vertex, again just using that same pattern. And so 1 unit left, 1 unit up, 1 unit right, 1 unit up, 2 units left, 4 units up, and 2 units right, 4 units up. And then once you've plotted those points, you can go ahead and connect them with a smooth line to create your parabola. Now that you've drawn your graph, all you have to do is look to see where the parabola crosses the x-axis. In this case, it never crosses the x-axis. Actually, if you saw the vertex, you would notice that it was already above the x-axis, and since this is a positive a value, your points were going up. So you would know from the beginning that it would never cross the x-axis. And when your parabola never crosses the x-axis, you just say that there is no solution. Here is another example similar to the previous one. We're going to solve 2x plus 5 equals to negative x squared by graphing. So first, I want to set my function to 0, since we see here that it's actually equal to negative x squared. So all you would have to do is add x squared to both sides, and that would give you 0 equals to x squared plus 2x plus 5. Again, still following that ax squared plus bx plus c format, or standard form. And then to make it into your related function, just set your equation to y instead of 0. And now that you've done that, you have your function ready, and now you can find your axis of symmetry. Equation for the axis of symmetry is x equals to negative b over 2a. Your b value, looking at your equation, is positive 2, so plug in positive 2 for your b, and then your a value is just positive 1, so that would be negative 2 over 2, and if you simplify that, that would just give you negative 1. So your axis of symmetry is just x equals to negative 1, which is right here. So draw your axis of symmetry as a vertical line through negative 1 on the x-axis. And that's how it would look like. Once you've found your axis of symmetry, we're going to do the exact same thing as we've done for all our previous problems and find our vertex. So our axis of symmetry is x equals negative 1, so we know that that's going to be our x-coordinate for the vertex. So we're going to find the y-coordinate by plugging in negative 1 into our function. So that would be x squared plus 2x plus 5, and all you would do is substitute x for negative 1, and then that would give you negative 1 squared plus 2 times negative 1 plus 5. Negative 1 squared just simplifies to positive 1. 2 times negative 1 is negative 2, and then plus 5. 1 plus negative 2 would give you negative 1, and then negative 1 plus 5 is just positive 4. So your vertex would be at negative 1, positive 4, which is the point right here. Again, notice that your vertex is actually above your x-axis, and your parabola is positive, so it's going to go up. So we know right now that it looks like this is going to be a no solution. But let's go ahead and finish up our graph. So we would have negative 1, positive 4 as our vertex. Then it looks like we only have room on our graph to do 3 points. So I'm going to follow the general pattern of 1 unit left, 1 unit up, and then 1 unit right, and 1 unit up once again. And now that we have 2 points there, we can connect them with our parabola shape, and it would look like this. And again, as we suspected, our vertex is above the x-axis, and there's no way for it to cross the x-axis. So because there are no x-intercepts, we know that there is no solution to this equation. Here is just a brief summary of what we learned. So we learned how to solve quadratic equations by graphing. Of course, graphing is a little bit of a tedious process since you do have to find all your values and points to graph. We will learn a bunch of other methods in the later lessons. But for today, we learned that quadratic equations may have either 2 real solutions, 1 real solution, or no real solutions, and this is how they would look like on our graph as we saw in the problems. For 2 real solutions, your parabola would cross the x-axis at 2 points, and that would be your two x-intercepts. For one real solution, your vertex would be your only solution, and that means your parabola really only crosses the x-axis once, and that would be your vertex, and there's your one x-intercept. And lastly, you can also have no real solutions where your vertex is above the x-axis and your parabola never seems to cross the x-axis. And since you have no x-intercepts, there are no real solutions. That is it for today's video. Thank you so much for watching. If you ever have any general questions about how to do any problems or anything that I've done in the video, please feel free to reach out to me at kaylin.david24@gmail.com. As always, all information regarding tutoring, lesson requests, and additional practice are linked down below. I hope to see you in the next video.